A Brief History of Time by Stephen Hawking. Read by Mr. Narrator. Chapter 1, Part 3. Even those who realized that Newton's theory of gravity showed that the universe could not be static did not begin to think to suggest that it might be expanding. Instead, they attempted to modify their theory by making gravitational forces repulsive at very large distances. This did not significantly affect the predictions of the motions of the planet, but it allowed an infinite distribution of stars to remain in equilibrium. With the attractive forces between nearby stars balanced the repulsive forces of those that were farther away. However, we now believe that an equilibrium would be unstable if the stars at some region got only slightly nearer each other. The attractive forces between them would become stronger and dominate over the repulsive forces, so that the stars would continue to fall towards each other. On the other hand, if stars got a bit further away from each other, the repulsive forces would dominate and drive them further apart. Another objection to an infinite static universe is normally ascribed to the German philosopher Heinrich Albers, who wrote about the theory in 1823. In fact, various contemporaries of Newton has raised the problem, and the Albers article was not even the first to contain plausible arguments against it. It was, however, the first to be widely noted. The difficulty is that in an infinite static universe, nearly every line of sight would end on the surface of a star. Thus, one would expect that the whole sky would be as bright as the sun, even at night. However, if that happened, the intervening matter would eventually heat up and until it glowed as brightly as a stars. The only way of avoiding the conclusion that the whole of the night sky would be as bright as the surface of the sun would be to assume that the stars had not been shining forever but had turned on at some point of finite time in the past. In that case, the absorbing matter might not have heated up yet, or the light from the distant stars might not have reached us. And that brings us to the question of what could have caused the stars to turn on in the first place. The beginning of the universe had of course been discussed long before this. According to a number of worldly cosmologies and the Jewish, Christian, Muslim tradition, the universe started at a finite time and not very distant time in the past. One argument was for such a beginning was the feeling that it was necessary to have the first cause to explain the existence of the universe. Within the universe, you always explained one event as being caused by some other event, but the existence of the universe itself could be explained in this way only if it had some beginning. Another argument was put forward by Saint Augustine in his book The City of God. He pointed out that civilization is progressing, and we remember who performed this deed or developed this technique. Thus, man, and so also perhaps the universe, could not have been around all so long. Saint Augustine accepted as a date of around 5000 BC for the creation of the universe according to the book of Genesis. It is interesting that this date of 5000 BC is not so far from the end of the last ice age, about 10,000 BC, which is when archaeologists tell us that the civilization really began. Aristotle and most of the other Greek philosophers, on the other hand, did not like the idea of creation because it smacked too much of divine intervention. They believed, therefore, that the human race and the progress described above, and answered it by saying that there had been periodic floods of other disasters that repeatedly set the human race right back to the beginning of civilization. When most people believed in an essential, static, and unchanging universe, the question of whether or not it had beginning was really one of metaphysics or theology. One could account for what was observed equally well on the theory that the universe had existed forever, or on the theory that it was set in motion at some finite time, in such a manner as to look through it had existed forever. But in 1929, Edwin Hubble made the landmark observation that whatever you look, distant galaxies are moving rapidly away from us. In other words, the universe is expanding. That means that at earlier times objects would have been closer together. In fact, it seemed that there was a time about 10 or 20,000 million years ago when they were all at exactly the same place, and when therefore the density of the universe was infinite. This discovery finally brought the question of the beginning of the universe into the realm of science.